Alright, in this video we're going to be discussing the periodic table of the elements. And as you may know, the elements are the basic building blocks from which everything in our universe is made. And these are made up of atoms. And we're going to be talking about that in just a little bit. But first I want to focus on just what is a periodic table. And to do that, let's first of all talk about what is a table. Now, no, not that kind of table. A table is a way of arranging information or items so that we group things together with like characteristics. So this is an example of a two-dimensional table where we have a column, and things in a column might share a characteristic, and a row, and then a row might share the items in that row might share a characteristic, so that if something was in this position here, besides the item itself, we would know that it had certain characteristics based on our knowledge of the column and of the row. So to see how this would work with numbers, we could start listing out numbers across a page here, and we would list those numbers out until we got to the end of the page. Or if, on a computer screen or whatever, you'd eventually run out of some room and you'd have to wrap around and continue your numbers on the next line. And this is kind of the way we write on paper in books. You have a sentence, and the sentence moves along until you get over here to the end of the sentence and there's no room, so then you have to wrap around to the next line. And if you looked at a page of words, you would call it a table of words, because it's not a table. There's no characteristic that kind of holds, that is shared by all the first words on each line. It's just a page of words, and this is just over here is just a list of numbers. There's really nothing that has any characteristics that are very useful. To make a useful table, we can start listing out our numbers, but we want to find a meaningful place in which to wrap around and start our next row. So since we are in the base 10, what we call base 10, we have 10 different characters. When we get to 9, which is the last of those characters, we don't have another character to go forward, so we have to do something different. So that's a good point to wrap around and start our next row. And in order to make our number 10, what we do is we put a combination of a couple of these. So we pick a 1 and a 0, and we call that 10. And then we put two of them together, and we say a 1 and a 1, and a 1 and a 2, and so forth, until we go all the way across until we get to 19, which is a 1 and a 9. And of course, when we get to this point, we're out of characters, so we wrap around and we start our next row with the 2 being the leading digit, and we continue to count that way. And you can see this is starting to form a table, because the column here now has a shared characteristic, and that is that the least significant digit is the same, and that's the case for all of these columns, and our row has the most significant digit the same. And this is like when we have a calendar. If we look at a month of the calendar, we have a week that goes by and there are 7 days, and then we repeat the week after 7 days. And so after a period of 7 days goes by, we then repeat. And this is the same way, where this is a period of 10 numbers, and then we kind of repeat the pattern. So this has a period of 10 numbers. So we could call this a periodic table of numbers. So now that we have an idea of what a periodic table is, let's go talk about these elements. So elements are made of atoms. Actually, elements are atoms. It's just the more of that same kind of atom that you put together, you just make more and more of that element. But the atoms within an element, they're all the same kind of atom. And then from element to element, the thing that makes the elements different is the atoms that make up the element have a different number of protons in them. So let me try to explain. If we take the most simple element, element number 1, the atoms that make up that first element has all of those atoms, they only have 1 proton in them. So we can call this E1 for element 1. And then we can go to number 2 and we say all the atoms that make up element 2, or the 1 atom for the very small amount of that element, would only have 2 protons in it, and we can call that E2. So now we can start listing these out, E1, E2, and so on and so forth, until we have to ask ourselves, where do we want to turn around or wrap around to make our next row, so that we have a meaningful table and we have some meaningful characteristic throughout these columns. And to answer that, we have to say, what makes the characteristics of these elements? Well, we know that the elements have a different number of protons. But it turns out that the characteristics are really determined more by how the electrons move around the outside of the nucleus and how they move around those protons. In order to understand how the electrons move around the nucleus, we're going to start with a couple of rules. And the first rule is that unless you're at absolute zero temperature, electrons always move. Okay? And the second rule is that electrons are attracted to the protons in the nucleus. Okay, so we'll start off here with a little picture, and this picture is of a very simple atom. It only has one proton and one electron. And this is drawn in the form that we call the Bohr model, after Niels Bohr. And it's a very simple way of talking about electrons' position around the outside of the protons. And because the electrons are always moving, and it's drawn this way with this circle around here, we would imply that or one might presume that this electron is moving around this proton kind of the way the moon moves around the Earth. And while this picture kind of indicates that, that's not really what's going on. It's a much more complex movement of the electron. As a matter of fact, it's not in a circle. It's not even in an ellipse the way the planets go around the sun or anything. It's not in the same plane. It's really this electron moving in all three dimensions, up and over, down and around the side at weird angles, sometimes close to the proton, sometimes far away. It's just always moving. As a matter of fact, it's a very unpredictable path, and we really don't know where it's going to be. But the one thing we can say about it is that it's somewhere near the nucleus. We know it's always moving, and because it's attracted to the protons, it's not going to get too far away. So really all we know is it's somewhere around there. But we like this drawing because it's a way to represent the electron outside of the protons, and as we build more and more complex pictures with more and more complex atoms, it would get kind of crazy trying to draw this unpredictable path. So this is a very useful way to draw it, and so we're going to use this kind of drawing as we go forward to describe the movement of the electrons. So here we can get started with our most basic element, one proton, one electron. We call that E1. We list that here. And then we can get the next element, which we add a proton. And with that, we have an associated electron out here. And this little drawing here is a different way of drawing the Bohr model. It also shows the neutrons that are in at the nucleus. That may be of some interest. But this is element number 2, so we can go ahead and list that right here. Now at this point we have 2 electrons, so we need to talk a little bit about how these electrons behave around each other. But at this point in the video we are out of time, so we're going to stop here, and in the next video we will pick up and we will talk about how electrons interact with each other.